Hi, welcome to our math. Today I'm doing a series of videos on linear programming. Linear programming involves reading a story problem and, as always, coming up with an answer, but the answer takes a little bit more work. Okay, so let's start by figuring out what we want to figure out. A farmer plans to plant 2 crops. The cost of cultivating the first crop is $40, whereas the cost of the second is $60. Okay, has a maximum of $7,400 available. Each acre of the first is 20 hours of labor. Each acre of the second is 25 labor hours, and the farmer has 3,300 labor hours available. Okay, she wants to make a profit. It's 150 on the first crop and 200 on the second. How many acres of each should she plant to maximize the profits? Okay, so I'm going to say that X is representing the first crop, specifically acres of the first crop, and Y is going to represent the second crop. And when we read this, it says cost is one of my limiting factors, and the second is labor hours. Okay, so we have first crop, second crop. It says the cost of cultivating the first crop is $40. So if X is the number of acres, the cost is 40 times X. Whereas the cost of cultivating the second crop is $60. So that's 60Y. Okay, the farmer has a maximum of $7,400. That means that's a ceiling. You can't go above it, which means the money spent on these 2 crops has to be less than or equal to the $7,400 available. Each acre of the first crop takes 20 labor hours, so 20 hours per acre, or acre. And each acre of the second is 25, so 25 per acre. And the total available labor hours is 3,300. So that's, again, our maximum. So it has to be less than or equal to 3,300. My last 2 equations I always put in here. X is greater than or equal to 0. Y is greater than or equal to 0 because you cannot cultivate negative crops. Now, I just said I always put it in there. There are situations I don't, but they are when you have another baseline that you have to follow. We do need to avoid negatives. All right, so these 4 equations will define the possible number of crops that will satisfy the situation. But then our last thing is the profit. We get, for our profit, it's $150 per acre of the first crop, and $200 per acre of the second crop. Okay, now that we have all of that, I'm going to scooch the story problem up because we need the room for the rest of the process. Okay, we want to maximize our profit. The first thing we need to do now is we need to graph this set of inequalities. To start that off, when I graph my inequalities, I don't try to get into slope-intercept form. I try to graph with my intercepts. So I'm going to take 40x plus 60y. I'm going to say equals to 7,400 because this is just to map out my graph, and the inequality is not needed until I do the shading. The way I'm going to graph this is I'm going to, like I said, do my intercepts. So I'm going to say if y is equal to 0, then 40x is equal to 7,400, or x is equal to 185. If x is equal to 0, so 60y is equal to 7,400, then y is going to equal 123.3 repeat. Normally I go to fraction, but for simplicity right now, I'm just going to go to decimal. For my second equation, I have 20x plus 25y equals 3,300. Again, if y is equal to 0, then 20x is 3,300, or x is 165. And if x is equal to 0, then 25y is 3,300, or y is equal to 132. So if I do a quick sketch of this graph, My two x-intercepts are 165 and 185. I don't care at all about scale in this process. My y-intercepts are 123.3 repeat and 132. The 185 attaches to the 123.3 repeat. And the other two, 132 and 165, connect. Okay, so here's a basic graph. For the first equation, it says that the two added together are less than. That means it's below the line. As long as your y is positive, you can do it that way. We can also test a point, but for this one, I'm going to go a little bit faster and say that all of the ordered pairs that satisfy this have to be less than this line, so I need to be less down. Same for the second one. All of the labor hours have to be less than down from this line. My last two equations force me to be in quadrant 1. X is greater than equal to 0 is to the right of the y-axis. Y is greater than or equal to 0 is above the x-axis, which means that this kite area is the sum total of ordered pairs that satisfy this situation. So we have this 0, 123.3 repeat as a corner. We have 0, 0 as a corner. We have 165, 0 as a corner. And we need to do a little bit of work to figure out our last corner. So the way we do that is we need to solve these together. 25 doesn't go into 60, but 20 goes into 40. So what I'm going to do is I'm going to take line 1 and subtract 2 times line 2. So line 1 is this 40x plus 60y equals 7,400. When I subtract 2 times line 2, actually what I'm going to do is I'm going to multiply through by negative 2. So negative 40x minus 50y equals negative 6,600 and add down. I find that if you multiply through by a negative and add down, you're more likely to get it right. All right, so 10y is equal to 800, which means y is equal to 80. I'm going to put that into my first equation. So I'm going to have 40x plus 60 times 80 is equal to 7,400. 40x plus 4,800 equals 7,400. 40x equals 2,600, or x is equal to 65. I quickly test out. The second one is 20 times 65 plus 25 times 80, really equal to 3,300. It works, so I'm good to go. So my last corner is 65, 80. Okay, so the thing is, though all of this infinite number of points satisfy for the number of crops, acres of each crop, the maximum profit is going to come out of one of these 4 corners. So I'm going to test them all out. I'm going to start with this 0, 123.3 repeat. I'm going to put it into this profit equation. So if I do 0 acres of acre 1, and I do 123.3 repeat of acre 2, my profit is going to be $24,666.67. All right, now if I do 65 and 80, it's going to be $150 times 65 acres plus 200 times 80 acres, which is going to come out to a total of $25,750. And then when I test my next one, 165 and 0, my profit is 150 times 165 plus 200 times 0, which is going to be 24,750. And believe it or not, I always test my origin just so I've fully tested all of my points. So to maximize profits, the farmer should plant 65 acres of the first crop and 80 acres, oh, sorry about that, of the second crop for $25,000, $25,750. All right. I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks.